everyone. In this lecture, we are going to see the force measurement. The name of the subject is Industrial Measuring Instrument. I am Dr. Abhas Kanungo from Electronics and Communication Department, Kite Group of Institution, Ghaziabad. In this lecture, we are going to see the basic measurement of force, how the force can be measured and what are the various possibility when we are going to measure the force. Okay. In last class, we have discussed about the displacement devices, various displacement devices. So, the basic if you will talk about the Newton's law, according to the Newton's law, when a force F is applied to the body of the mass m, it accelerates the rate a. So, mathematically the force F is equal to ma. So, from the above equation, it can be clear that the unknown force applied to the body of the mass m can be measured by measuring acceleration of that body. So, the basically the proportional the force F is proportional to the mass m and the acceleration. So, the force may be defined as a that produces resistance or obstruction to any moving body or changes the motion of a body tends to produce this effects. Okay. So, when a object is stationary, we want to move this any object, then we require the force to move that object, or the force is usually measured by applying it to the calibrated device which is resists the force and indicate or records its magnitude. So, there are basic various devices to measure the force that can be used to measure the force or the pressure, because a pressure is also proportional to the force. So, there are basic various arrangements that can be used to measure the force. So, there are various techniques that can be used to measure the force. First is force measurement using accelerometer, second one is force measurement using vibrating wire sensor, third one is force measurement using the load cell. In that we are having two category, first is cantilever beam type load cell and the second one is column type load cell. So, first is the force measurement using accelerometer. So, it is the basic arrangement of force measurement using accelerometer. So, by using accelerometer of any type, the acceleration of a body known mass due to the applied force can be measured. As we have seen in the formula that F is equal to ma. So, it will be proportional to the mass of the body and the acceleration. So, by knowing the amount of acceleration in the body of mass m, we can know the force. So, by using accelerometer of any type, the acceleration of body of known mass due to the applied force can be measured. Then by using Newton's law, the mass acceleration, the applied unknown force can be calculated, but particularly when we use the accelerometer for force measurement, it is limited because of force are not free, but they are part of the system. So, it is very difficult to decouple this forces. Also, this technique is useful in measuring some transient forces. So, the because the acceleration provides you motion in the body, so also it will provide you or it will give you the transient forces of motion, because it will be force is proportional to the mass and the acceleration as well. So, the application of this technique is in calibration of forces produced by thrust motors or in space vehicle. So, there is basic application when we are using the accelerometer by using the force. This will be the basic method of force measurement. Now, the second technique, because the previous technique was very basic and very simple, because in the formula of force we are having that F is equal to ma. So, that will be proportional to the mass as well as acceleration. So, by providing the acceleration in any body which is having mass m, we can know the force. The second method of force measurement is using the vibrating wire sensor. So, a wire is kept vibrating at its resonant frequency by using variable frequency oscillator. So, in that arrangement, one variable frequency oscillator can be used. Here we can see that the resonant frequency is given by from the variable frequency oscillator, that frequency is 0.5 by L that is 0.5 by L under root m by t. So, that will be the resonant frequency which is given, and that here you can see that f is give you the resonant frequency, L is the total length of wire which we are using, m is the mass per unit length of the wire, and T is the tension due to applied force. So, the formula for resonant frequency can be given as 0.5 by L under root m by T. So, that will be the basic formula that can be used when we are using the force measurement by vibrating wire sensor. Now, that is the basic arrangement for force measurement using vibrating wire sensor. So, it is clear that when applied force changes, the tension changes and hence the output frequency changes, because you can see the force, if you will provide the force from this direction, because of this applied force changes, and because of the applied force changes a tension changes in the that wire. Okay. So, because of that tension changes, the variable frequency which we have seen in that formula, that is proportional to the mass of the wire m, length of the wire and tension due to applied force. So, when we provide the force, when we applied the force from this direction, a tension will be created in that wire, and because of this tension the frequency will also be changed, because you can see that frequency here is proportional to the 1 by root T, and where T is the tension which we are getting from applying this force. Okay. So, because of this a frequency will be changed, and the change in the frequency can be measured with the help of that formula which we have seen earlier. Okay. So, because of this applied force can be measured. So, thus by measuring the output frequency of the local oscillator, the output frequency can be measured with the help of oscillator, and the force applied to the wire can be calculated, and this is the basic arrangement for measuring the force of a vibrating wire. So, by measuring the frequency a force can be calculated. So, here in this we have calculated the force in terms of frequency, force in terms of frequency. So, there is a basic arrangement when we are using any type of transducer or any sensor, then we are getting any physical variable in terms of various energy forms. Okay. Here we are getting the force in terms of frequency. The next arrangement is a force measurement using the load cell. So, the load cell is a electromechanical sensor that is used to measure the static force as well as the dynamic force. It is the most widely used transducer that will be used in many industrial applications, which can be handle wide range of forces. The material used for load cell should possess linear stress strain relationship. That means what? When we provide the force on any wire or anything, then we are having one side we are having the stress and one side we are having the strain. So, that stress strain curve should be proportional to each other. So, that will be the basic characteristics of instrumentation also, that a good instrument should produce the good linearity. Okay. So, when we provide the stress on any object, it will also provide you the equivalent strain, and that will provide you the linear relationship between the stress and the strain. So, the material used for load cell should possess the linear stress strain relationship. Also, it is having the low hysteresis and very low creep over during the loading period. So, the loading effect should be minimized. Also, it should have a low hysteresis and the very low creep over during the loading period. As we have seen that when we increase the input, the output follow the input linearly, but when we are minimizing the input, output does not follow the same curve. That term is known as the hysteresis. So, also the when we are using the load cell, it should provide the low hysteresis and very low creep over during the loading period. Also, the various elastic materials suitable for the purpose are medium to high carbon steel of chromium, moderium and the precipitated hydrogen stainless steel. So, in terms of material, when we are using the load cell, we should get the caution of that. The first arrangement is cantilever beam type load cell. When we talk about the cantilever beam type load cell, these are the types of load cell found in small platforms for measuring lighter loads. They are usually found in bench scales, money counting machines, part counting scales in process wetting equipments. On the top and bottom surfaces of the beam, 4 strain gauges are bonded. So, basic mechanism we will use in the cantilever beam type load cell is strain gauge. Okay. So, basic work of strain gauge is that can be used to measure the strain. So, we will use in the cantilever beam type load cell, we will use the 4 type of strain gauge. On the application of the force F at free end of the cantilever beam, a bending moment develops in the beam which is proportional to the applied force. With reference to the direction of force shown in the strain gauge 1 and 3 measures the tensile strain developed on the top surface, while strain gauges 2 and 4 measures the compressive strains developed at the bottom surface. So, the maximum deflection occurs at the free end of the beam, while the maximum strain develops at the fixed end of the beam. Thus, in cantilever beam type load cell, applied force can be measured as a function of deflection or strain. So, in this basic arrangement of the cantilever beam is that in that one part is fixed, and one part is movable, and when the load is applied or that load when F is proportional to m. So, any type of mass or load will be applied that will be equivalent to force. So, on the free end when we applied the load, this beam or this column will be moved. We have used the 4 strain gauges, that is 1, these are the strain gauges, that red one is or the strain gauges 1, 2, 3 and 4. So, 1 and 2 strain gauges are used for to calculate the tensile strain that will be caused by this load, and that 2, 3 and 4 the strain gauges this 3 and 4 are used to give you the compressive strain on the load. So, the proportional, because of this load, a proportional output can be generated and that can be calculated because of this strain gauges. Okay. So, one end of this is fixed and one end of this is movable. So, that is the free end and this is the fixed end. Okay. And when we provide the load on this, and that load is equivalent to the force, because force is directly proportional to the mass. So, when we provide the force on that, the strain gauges 1, strain gauges 1 and strain gauges 2, that will be used to give you the tensile strain, and that strain gauges 3 and strain gauges 4 will give you the compressive strain. So, that will be the basic principle of basic working of cantilever beam type load cell. The next arrangement is the column type load cell. So, the simplest method for measuring the unidirectional forces is to use the column or rod type load cell. So, that can be used in case of the tension or the compression. Also, it will also use the strain gauge as a basic element to measure the force. So, by using the electrical strain gauges attached to the body, the stress developed due to the force on the loading can be measured. So, the basic principle of column type load cell and the beam type load cell is same, that in that case we will use the strain gauges, and when we use the strain gauges, when we applied the force, the equivalent electrical output we will get. So, the column type load cell structure is shown in the next figure. We will see that when the steam cylinder is subjected to a force, it tends to change in the dimension. On this cylinder, if strain gauges are bonded, the strain gauges also is stretched or compressed, causing a change of its length and the diameter. This changes in the dimension of strain gauges causes its resistance to change. This changes in resistance or the output voltage of the strain gauges becomes a measure of applied force. So, that will be the, we will see the basic arrangement of that. Now, here the 4 strain gauges are used. This is the R1, R2, R3 and R4. So, when we provide the load, because the structure is type of column, when we provide the load and that load is equivalent to the force. Okay. So, when we provide the load, a compressive this cylinder, the shape or the dimension is changed, and also you can see that 4 strain gauges we have used. One is R1, R2, R3 and R4, R1, R2, R3 and R4. So, this arrangement is here only. Okay. So, when we provide the load on that, the work of basic strain gauge is when we provide the force, then resistance changes, and when resistance changes, that resistance changes with respect to this force that can be measured with the help of strain gauge. So, here we have used the 4 strain gauges over this. In that we have used the R1, R2, R3 and R4. So, 2 strain gauges is used for the tensile strain. Here we can see that R1 and R4 is used for compressive strain, and R2 and R3 is used for tensile strain. Okay. R1 and R4 are used for compressive strain and R2 and R3 is used for the tensile strain. So, when we provide the force, the resistance of R1 and R4 will give you the change in the tensile strain, and the resistance of R3 and R2 will give you the change in the compressive strain. So, that will be provide you the equivalent output in electric form with proportional to the force. So, that is the basic arrangement of the column type load cell, in that the force can be measured with the help of arrangement of various strain gauges. Okay. Now, there are various advantages of load cell, in that we have used the column type load cell, beam type load cell, because the load cells are temperature compensated. There are various advantages of load cell. Also, they have a stable system with no moving parts and the linkage, because we are not using any type of moving parts in the strain gauges. So, as we have seen lastly, we have seen the displacement measurement. In that we have used the mechanical devices to measure the displacement. So, when we have used the mechanical arrangement to measure the displacement, we are having some type of friction losses because of the moving parts we are using. But in case of load cell, when we are measuring the force with the help of load cell, we are not having any type of moving part. So, that will be the one advantages of load cell. A few of them have multiple strain gauges incorporated, reduce position effect. So, in that we can see that in the strain gauges we have used, because there is no moving parts, and also in the beam type load cell or in the column type load cell, we have used the arrangements of multiple strain gauges. We have seen that in beam type load cell we have also used the 4 strain gauges, and in column type load cell also we have used the multiple strain gauges. So, that will increase the accuracy and the resolution of the devices. Also, the any standard strain gauges bridge measuring readout device can be used with the load cell. So, that will be the basic arrangement, that any standard strain gauge bridge measuring readout device can be used with the load cell. So, basic principle that we will use, that we have used the strain gauge. The basic principle that we have used in the load cell is the strain gauge. So, the basic principle of strain gauge I have already told you, when we provide any type of force or any type of strain in the wire, the resistance of that wire can be changed. So, the resistance is equivalent to, we know that resistance is equivalent to rho L by A. So, when we provide any type of force, then the resistance changes, and when the resistance changes, the length in the wire, if this is the wire, and if I am providing any type of force in that, then the resistance can be changed, and that resistance can be changed because of the change in area and change in the length by providing the equivalent force. So, that will be the basic principle of strain gauges, and that resistance change can be measured, and that will be proportional to the force employed to change the area and the length of the wire. So, that rho is the resistivity, L is the length of the wire, A is the area. So, that is the basic principle of strain gauge, because in the load cell we have used in the both the category beam type load cell and the column type load cell. In both areas we have used the arrangement of strain gauges, and that strain gauges will provide you the multiple strain gauges will provide you the tensile as well as the compressive strain that will be causes because of the force or the load. So, that are the various advantages of the load cell that can be used, and there are various applications of load cell in the industry. Also, a few of them can use the multiple strain gauges to incorporate it to reduce positioning effect.